Hello everyone, I just continue giving you more examples for differentiation rules. We have fifth root of 3x to the 4 minus 5x plus 1 all cubed under the radical sign. It seems to be like a complicated function, but we're going to use the shortcut formula that I explained in the past lectures. So we're going to say here, what plays the role of u is the quartic polynomial, what plays the role of p is the exponent of 3, what plays the role of m in the index of the radical is actually the 5, which is representing a fifth root. So the answer is right before your eyes. It's going to be pu prime. So that's going to be 3 times u prime, which is 12x cubed minus 5x. Okay, so that's pu prime divided by m, in this case 5. And then it's going to be fifth root of, okay, u itself, which is 3x to the 4 minus 5x plus 1, and then raised to the exponent of m minus p. So m minus p is going to be 5 minus 3. M minus p, 5 minus 3, which is 2. So we write 2 here, and this would be the very final answer. As you see, it was a complicated function, but we got the answer in one shot thanks to this formula. So if you substitute p equals 1, if the exponent of the radicand is 1, then this formula becomes the formula I gave you before. And then if you substitute 2 instead of m in that formula, it becomes like the simple case of square root of u. Okay. This is another example, but I see a product here. Okay. So this is u, that is v. I'm going to say u prime v, which is going to be 6x times square root of 2x minus 1, and then plus v prime u. So this is u, but v prime is the derivative of the radical. So here, if I want to use the long methods, it's going to be very time consuming, but if I use the shortcut formula, in 1 second I can find the answer. So square root of 2x minus 1 is square root of u. The answer is u prime, which is going to be 2, okay, divided by 2 times the square root of 2x minus 1. All right, so I can find the answer very quickly. Square root of 2x minus 1, just like square root of u. The derivative is u prime, which is 2 in the numerator, divided by 2 root u, which is 2 square root of 2x minus 1. You can simplify, of course, 2 over 2 cancel out each other. You can say like this is 6x times the radical, and then plus 2 and 2 cancel out each other, 3x squared divided by the radical. And if you want, you can find the common denominator and all of that. But this is the final answer. So you see that in the middle of a product rule kind of question, you may need to use these shortcut formulas. They become very handy. That's the point I want to make. This one is a cube root in the top, a square root in the bottom, right? So I know it's a quotient. We have to apply the quotient rule right there, u over v. But I'm going to say, okay, u prime, which is the derivative of the numerator, I can find that using this formula, this shortcut formula here. So you see how handy they become. It's going to become u prime, which is 2x, and divided by 3 times cube root of x squared plus 5 to the exponent of 3 minus 1, which is 2. So that's the derivative of the numerator times the denominator, root x, minus derivative of the denominator, which is 1 over 2 root x, times the numerator, which is cube root of x squared plus 5, and then all over the denominator squared, which means simply x, because square root x all squared will be just x. I know this is not simplified, I leave it as it is for now, but I just want to say that complicated functions like this, you can find their derivatives using these handy shortcut formulas. Imagine if you wanted to find this derivative separately, it would be a lot of work. So it's not a bad idea to know those formulas and apply them. Now, 2 empty boxes left here. I just kept it for trigonometric functions. We have to talk about trigonometric derivatives extensively later on. But for now, I just say that y equals sine x. If you have sine x, the derivative of sine x is cos x. Okay? It is not the place right now to prove it, but we will prove it later on. But for now, I just let you know about the formulas. The derivative of sine x is cos x, and then the derivative of cos x is negative sine of x. Okay? Just to know the formulas. Now here we have a situation where we can apply these formulas actually. So x squared times sine x, this is a product. Again, you have to recognize the products from now on. This is one function, quadratic function, times sine function, another function. So that must be in the form of u times v, right? So the derivative of first times the second, so 2x sine x, plus derivative of second times first, which is x squared cos x. That's the final answer. You can, of course, factor x out if you wish. It's going to be 2 sine x plus x cos x, but that doesn't matter. This one is another exercise. It says cosine of x, but then cos to the exponent of 10 of x. Okay, this is actually cos of x, the whole thing raised to the exponent of 10. And this reminds me of this formula, u to the exponent of n. So here what plays the role of u is not a polynomial, it's actually cos x, okay? So cheating from the formula, it says n in front, which is 10, and then it says u prime, which is derivative of cosine. We just said it's negative sine x, so you just write that down. And then it says u to the exponent of n minus 1. So that would be cos of x to the exponent of 10 minus 1, which is 9. So cos to the 9 of x. And minus 10 sine x cos to the 9 of x would be the very final answer for this exercise. So I just want to give you a taste of how we combine those product rule, quotient rule, or those differentiation rules with the derivatives of sine and cosine. Okay, so for now, this much enough, but you keep practicing and doing as many exercises as you can. Thank you.